Okay, so the chapter we are covering is chemistry of the environment, and we've talked about water and water pollution. Now, yesterday's class we talked about artificial fertilizers and the air. It wasn't recorded, right? So I'll just quickly go
What?
over it on,
Oh, okay.
yeah. So I'll just quickly go over that content on the whiteboard right now, and then we'll carry forward with the remainder of the chapter and actually hopefully complete it today. Alright, so you've got artificial fertilizers. Right, and so when plants, right, they utilize nutrients from the soil, and these need to be replaced or replenished. And so for those, right, artificial fertilizers used containing essential nutrients. Right, and so the main ones are ammonia, or in fact nitrogen, phosphorus, and potassium. Right, and so together, taking their chemical symbols, these are called NPK fertilizers. Right, now how much of each do they have depends on the kind of fertilizer. Maybe you want one which is has a higher percentage of phosphorus as compared to the other two, so you go for that particular one. Right, in what form are they added? So nitrogen is basically added in the form of ammonium salts. Right, so ammonium salts. So you can have uh, right, ammonium phosphate, so that's NH4. Right, potassium is added as potassium chloride. You can also
Okay.
have you can also have ammonium nitrate, so NH4NO3. You can also have ammonium sulfate, right? And so you're adding sulfur, and then there's some other like iron and magnesium, right? And some other elements that the plant requires. So those are also, although they're required in lesser amounts, right? So sodium, copper, but these can also be provided as obviously supplements in the fertilizers, or as separate chemicals. Now, problems, because they are artificially rich in all of these nutrients, right? If and when, right, fertilizers are leached into water bodies, so when fertilizers are washed away with rainwater or some other way, excuse me, into a nearby stream or river or lake. And so what that does is that dramatically increases the concentration, the levels of these nutrients in the water, right? And what that does is it promotes rapid growth of algae or algae.
Okay.
Right now, right, because this these nutrients are provided from the leaching of fertilizers, not the water body doesn't normally have those high levels of these nutrients. So once the algae grows rapidly, it starts dying off.
Yeah.
Right, it can't be sustained,
Yeah.
and so it starts to decay and decompose, and in that process the dissolved oxygen in the water is used up, and when the dissolved oxygen is used up, aquatic life suffocates. And if it gets pretty bad, they obviously end up dying. And so what you end up with is, for all intents and purposes, a dead body of water. It is not livable at all. This whole thing is called eutrophication. Oops. Okay.
Yeah.
So that's about the artificial fertilizers.
Okay.
Then you have air. Right, and so what we need to know is air is, right, the composition of air. It is 78% nitrogen, 21% oxygen, right, and the remaining are other gases. It's a mixture of carbon dioxide and other noble gases. Now, right, oxygen is obviously essential for respiration, right? So for all living organisms. The carbon dioxide, right, even though it's only 0.04% currently. Now, the thing they tell you in the book is that it used to be 0.03%, but due to human activity, pollution, the percentage actually went up, and that is a bad thing, right? You'd say, oh, well, it's good. Well, no, right? It's not. But anyway, right? We'll get into that later today. So 0.04%, and so that's essential for, right, all plant matter, let's say, because, right, it is used in the process of photosynthesis, right? Where they've given you the equation, so it's 6CO2 plus 6H2O, right, giving you C6H12O6 plus 6O2. So carbon dioxide is used along with water, right, in the presence of light and using a substance called chlorophyll in the plants, giving you glucose and obviously oxygen, right? So carbon dioxide is important for photosynthesis, right? If we didn't have carbon dioxide, then we wouldn't be having plants surviving, and that would cause a problem because plants also give up oxygen which we breathe. We just talked about that. Now, the problem with the increasing percentage of carbon dioxide is going to cause global warming, right? And so, as I mentioned, we're going to come to that later, which
Okay.
is which is not, right? So, it, right, what it does is it causes it's considered a greenhouse gas, right? Again, not in the percentages that are naturally present, but right, if there's excessive production of it, then right, it is considered a greenhouse gas, and why that is we'll talk about, and that leads to global warming. Now, that was review of yesterday's topics. Today we are talking about atmospheric pollution. Right, so most of this by the burning of fossil fuels in any form, whether that's coal or petrol or anything else, right? Fossil fuels, excessive use, whether in industry or in cars or wherever it is. Point is, if fossil fuels are being burned, then, right, the products of that combustion are harmful to the environment. Okay, so that is like, it's sort of stretched out and explained, right? And they talk about, population increase is causing that as well, and blah blah blah, right? But
Yeah.
uh, right, its primary source is fossil fuels. So when you have certain pollutant gases, most like all of these are gases, then uh, right, they contribute to atmospheric pollution, which is obviously polluting the air and polluting the water, right? So what we're talking about, and right, it's most, not all, so we're going to mention something else as well. And so we're talking about pollution, polluting air and water, right? Because in the book they mention, right, the environment, atmospheric pollution or environmental pollution, and the environment is everything in the surroundings of an organism that possibly influence it. I'm just putting that here. Everything in the surroundings of an organism that could possibly influence it. So, what are the main culprits? Right? You've got carbon monoxide, right? Carbon monoxide. It is caused by the incomplete combustion of carbon containing fuels. So, we've talked about this earlier, right? When there is insufficient oxygen, then what you end up with is carbon monoxide.
Yeah.
Right? It is a toxic gas, so obviously it's problematic. And so, right, how can we solve the problem or at least lessen it? Is right, one source is from car exhaust, so vehicle exhaust is one source. And if it's if you're talking about vehicle exhaust, you can, right, fit catalytic converters, right, in the exhaust of a car. And what that does is it converts carbon monoxide to carbon dioxide. And now, right, we just talked about increased levels of carbon dioxide. So it's not, you know, helping as much because raised levels of carbon dioxide are problematic in and of themselves. But at least it's not toxic. So, right, it's not a win-win. It's just okay, fine. So if it's like 100% bad, now it's like 70% bad or 60% bad.
Yeah.
The next thing you have are what are called particulates, right? So those are actually particles of incomplete combustion of, again, right? So they are from incomplete combustion, and so some of the carbon is not combusted at all, and so you've got particles of carbon, right? And so the problem they can cause is respiratory problems or respiratory distress or disease. And how you could solve that problem, uh, adding substances such as ethanol to reduce how much of these are produced. So this would reduce
Yeah.
the formation of these particulates.
Okay.
So there are less particles of uncombusted carbon being released. And again, right, this is in the context if you are burning fuel, right, and so you add ethanol into that fuel, and this would have, right, the desired effect as mentioned. Next up is methane, right? So that's CH4, and